From the moment we're born, we all need to breathe air. We need even more during exertion. If patients are suffering from breathing difficulties, nurses will give them oxygen masks to help them breathe. We breathe to take in oxygen from the air. But where does this oxygen, so important to mankind, come from?
Oxygen comes from the air. To understand how we get that oxygen from the air, we first need to know all about air and what it's composed of. Air is a mixture of many gases. They include oxygen, nitrogen, carbon dioxide, water vapor, and, in smaller amounts, rare gases like helium, argon, and so on.
To identify the composition of air, we need to use advanced scientific instruments.
That's right. If we want to know what gases air contains, we have to use scientific instruments like this mass spectrometer. In this mass spectrum chart, we can see many lines of different height. Each line represents a different gas.
Why does each line represent a certain kind of gas?
The principle of mass spectrum is very complicated. To put it simply, different kinds of matter give off different spectra. So by measuring the spectrum of each gas, we can tell which is which.
Nitrogen is the largest component of air at about 78%. The next largest is oxygen at 21%. Carbon dioxide is just 0.03%. In conditions of high humidity, air contains a high percentage of water vapor. At low humidity, it contains less water vapor. Finally, there are small amounts of rare gases like helium and argon.
The percentage of component gases in the air is more or less fixed. However, before entering enclosed spaces to work, it is always advisable to ensure safety by checking the air's oxygen content with a measuring apparatus.
Inside this enclosed room, there are many gas pipes. Before allowing workers to go in for inspection or maintenance, we have to measure the oxygen content to ensure it is safe. The process is simple. We place a tube connected to this apparatus in the room. On this panel, we can see the readings for percentages of various gases, such as oxygen, hydrogen sulfide, carbon monoxide, and explosive gases inside the room. To ensure that there's a sufficient supply of fresh air in the room, we use this fan to pump air in continuously.
In the laboratory, we can use a simple experiment to find out how much oxygen there is in the air. Let's take a look at the steps. First, place a small piece of cotton on the tip of an injection needle. Then drip 1 or 2 drops of alcohol onto the cotton. Close the valve on this tube. Place an empty 1-liter round-bottomed flask upside down onto the stand. Ignite the cotton on the needle and place it inside the flask. Tighten the stopper so the oxygen inside the flask can be consumed. When the oxygen inside the flask is used up, the flame is extinguished. Now insert this tube into water, open the valve, and observe what happens at the tube opening. We can see that water flushes into the flask like a fountain. By measuring the volume of water in the flask, we can discover the volume of oxygen gas used up by the burning. In this experiment, for example, the amount of oxygen previously in the flask, as shown by the water in it, is 205 milliliters. The capacity of the flask, hence the original volume of air inside, is 1,000 milliliters. In other words, the oxygen percentage is 205 milliliters on 1,000 milliliters times 100%, which equals 20.5%. We can repeat the experiment several times and calculate the results. By doing this, we'll obtain a more accurate percentage. We can also use a burning candle. Place it in a basin of water and cover it with a gas jar. By the time the candle stops burning, the water will have risen to about 1/5 of the jar's height.
Both experiments show that the amount of oxygen in the air is about 21%. To test for oxygen, we can insert a glowing splint into a gas jar. If the splint relights, it shows that the jar contains oxygen. To test for carbon dioxide, we can use lime water. This cylinder contains carbon dioxide. Carbon dioxide turns lime water milky. We can also test for carbon dioxide using a hydrogen carbonate indicator. Carbon dioxide turns the indicator yellow. Meanwhile, we can use a strip of dry cobalt chloride paper to test for water. For best results, the test paper should always be kept dry by placing it in a desiccator. If we place the test paper on water or ice, it turns from blue to pink. How can we obtain different gases from the air?
We use distillation to isolate oxygen, nitrogen, and argon from the air. We call this process separation of air. It consists of 5 steps. After filtering and compressing the air, we feed it into this condenser, where the water in the air condenses and is separated out. Here, we cool the compressed air to at about 5 degrees Celsius. By passing it through this dryer, we remove the minute amounts of carbon dioxide. The air then goes into this freezer, where it is cooled to approximately minus 107 degrees Celsius. From there, it is fed into the fractioning tower, where liquid oxygen, nitrogen, and argon can be obtained at different temperatures. You can see that the connecting tubes to these tanks are frozen on the outside. That's because liquid air is so cold that it freezes the water and the surrounding air.
Liquid nitrogen is extremely low in temperature. If we pour it out, it evaporates quickly. If we place plastic tubing in it, the tubing very quickly freezes and becomes hard and brittle. If we place an inflated ball in liquid nitrogen, the air inside the ball immediately contracts and the ball deflates. Once we return the ball to normal room temperature and pressure, it quickly re-inflates. All these phenomena indicate that liquid nitrogen is very low in temperature. As liquid nitrogen is so low in temperature, it is ideal for storing and transporting blood and umbilical blood, as it can stop the metabolism of any organic matter in the blood and prevent it from contamination. Liquid nitrogen can also help store the valuable umbilical blood.
Umbilical blood contains many stem cells. These cells may be very useful in future, as one cell can turn into many different cells. One day, an individual may need to use his/her own umbilical blood. We have to store it at a very low temperature, and liquid nitrogen is the best way to do this for long-term storage.
Liquid nitrogen is also used in treating some skin diseases. For instance, if we spray liquid nitrogen onto warts, the cells in them are frozen and die immediately. This is one way to treat skin infected with warts. But what is nitrogen gas useful for? As it has hardly any chemical reaction with other matter, it can be used in food processing. Look at this pack of biscuits. Why is it inflated? That's because it's filled with nitrogen. By injecting nitrogen, we displace all the air inside. Food doesn't easily become contaminated or stale in an air-free state. As there is no water present, the biscuits can also stay crisp. Filling the pack with gas also prevents the biscuits from getting crushed before it is opened. Carbon dioxide has several uses. For instance, it is used to manufacture carbonated soft drinks. Carbon dioxide can also extinguish fire. As the carbon dioxide is denser than air, spraying it displaces the air, and that in turn extinguishes fire. Some stage performances use mist to enhance atmosphere or create visual effect. One method of creating this is to use carbon dioxide. Carbon dioxide can be converted into dry ice of different shapes. The most important use for dry ice is freezing food.
Enjoy it.
Thank you.
Thank you.
The largest consumer of dry ice in Hong Kong is the Airborne Catering Company. Dry ice, or solid carbon dioxide, has a temperature of approximately -56 degrees Celsius. It is ideal for freezing food. Oxygen is the most important gas to us, as we need to breathe it constantly. Therefore, oxygen is mostly used in Hong Kong for medical purposes. Gas suppliers instill liquid oxygen into special tanker trucks to transport it to hospitals. The liquid oxygen is then transferred to the hospital storage tanks. Once it is converted back into gas, the oxygen is sent via tubes to patients' beds. Apart from this, oxygen is also sometimes compressed and stored in cylinders to make it easier for patients to use while moving around. Even smaller cylinders are used on emergency ambulances, as they are more portable and easier to use. Have you ever wondered why the flames and sparks from fireworks have so many different colours? Many chemical substances, especially metallic ones, will, when burnt or placed under high temperature, produce different coloured flames. For example, burning carbon over a Bunsen burner gives an orange flame. When a strip of magnesium metal is burnt, it gives off an extremely dazzling white light. This white light is a very high temperature flame. As fireworks contain various metallic compounds, their burning results in a colourful display.
Through simple experiments, we can see that burning metallic compounds produces flames of various colors. Dip a platinum wire into a metallic compound and then place it in fire. Different metallic compounds produce flames of different colors.
Finally, what is the process of burning?
Burning is a chemical reaction between substances in which various forms of energy are released all at once. Burning releases heat and light in the form of a flame. Three conditions are required for burning. There must be something to burn, which is the fuel. There must be oxygen, which supports burning, and a high temperature. In science, we call these three elements the fire triangle.
During burning, different materials release different amounts of heat and light. These different amounts of light can be seen in the form of different coloured flames. During a barbecue, the yellowish flames of burning charcoal indicate a relatively low temperature. The blue flame of burning gas fuel indicates a higher temperature.
There is a close relationship between oxygen and burning. Take the Bunsen burner in the school laboratory, for example. If we close the air hole, the flame is yellowish at a lower temperature. When we open the hole to let in more air, more oxygen supports the burning of the gas, and the flame then turns blue at a higher temperature. When we close the air hole, there is an insufficient oxygen supply. The yellow flame cannot provide enough heat to change this glass tube. But when we open the hole to allow more air in to facilitate burning, the flame turns blue. And the glass tube soon softens enough through the high temperature to be bent. This demonstrates that with more oxygen, fuel burns better. This is how the industrial oxyacetylene torch operates.
In industry, the oxyacetylene torch is connected to oxygen and a fuel called acetylene. This is what we call a weld gun. Once it's connected to the gas and ignited, the acetylene that comes out burns in the air with a yellowish flame. Its temperature is relatively low. If we adjust the gas flow to allow more oxygen in, the temperature becomes very high. Using this extremely high temperature flame, workers can weld and cut steel plates. Apart from fuel and oxygen, high temperature is also necessary for setting a material on fire. As long as there's adequate oxygen, a material will catch fire when it reaches a certain temperature. Place a piece of paper inside a high-temperature furnace. When the temperature reaches the ignition point of paper, the piece of paper will catch fire and burn spontaneously. In general, flammable materials burn at a relatively low temperature. That is why we have to be especially cautious when handling them.